Let's dive into a real-life cosmic drama. We're talking about an asteroid big enough to wipe a city off the map, and the incredible story of humanity's first ever attempt to actually fight back. So get this, in 2028, a city-killer asteroid is going to swing back through our cosmic neighborhood. We actually had a pretty close call with this exact same one not too long ago, which really makes you wonder, if one of these things was really on a collision course, are we actually ready for it? All right, so let's start with that close call. This whole thing kicked off because of one specific rock, an asteroid named 2024 YR4. And for a little while there, it caused some very real, very serious alarm. What's wild is just how fast this whole situation unfolded. Back on January 29th, the big asteroid warning network suddenly flagged this thing. Why? Because its impact risk ticked up over 1%. Now, I know, 1% doesn't sound like a lot, but in the world of asteroid tracking, that is absolutely enough to get everyone to sit up and pay attention. Then, by February 18th, the risk hit its peak, a 3.1% chance of hitting Earth in 2032. But just 5 days later, poof, more observations came in, and the risk dropped to 0. Everybody breathed a huge sigh of relief. But the story's not quite over. It's coming back for another look in 2028. So yeah, while 2024 YR4 isn't a threat to us anymore, at least for now, scientists are for sure still tracking it. In fact, the newest calculations give it a 4% chance it could smack into the moon in 2032. It just goes to show you, these cosmic paths are a real game of inches, which is why you can never, ever stop watching the sky. Now, this one asteroid, it's really just an example of a much bigger class of threat. So let's get into it. What exactly is a city killer? Okay, so it's really important to get the scale right here. When most of us hear asteroid impact, our brains immediately go to the dinosaur killer, right? A monster rock 6 miles wide that changed the entire planet. But that is not what we're dealing with here. A city killer, like 2024 YR4, is more like the size of a big jet. Look, it's not going to cause a global extinction, but it would absolutely cause devastating regional damage. It's a hugely serious threat, just not an end-of-the-world one. And here's the real kicker. It's not just the size, it's the insane speed. We're talking about an object hitting the atmosphere at nearly 40,000 miles per hour. I mean, that's like flying from New York to LA in less than 5 minutes. The amount of pure energy in that impact is it's almost impossible to wrap your head around. The sources we looked at paint a really grim picture. Listen to this description of a direct hit. It would leave a crater the size of Manhattan, and the shockwave alone would be powerful enough to flatten everything in a 30-mile radius. That's not a bad day. That's a catastrophe on a scale we can barely imagine. So that's the threat. It is real, and it is pretty sobering. But here's where the story gets really, really cool. Because we are not helpless. For the first time in the history of our species, we have actually tested a way to fight back. It was called DART, the Double Asteroid Redirection Test. And the idea was so simple, but also incredibly ambitious. Could we literally change an asteroid's course by hitting it with a spacecraft? It was our first ever real-world test of what they call a kinetic impact, basically punching an asteroid to save the world. The plan was pure science fiction come to life. NASA launched a spacecraft on a 10-month road trip out to an asteroid system. The target wasn't the big one, but its tiny moonlet, a rock called Dimorphos. In the final moments, the spacecraft took over, steered itself, and slammed head-on into Dimorphos at 14,000 miles an hour. And then, every telescope on Earth turned to see, did it actually work? Oh boy, did it work! Just look at the data. Before the smash-up, it took Dimorphos 11 hours and 55 minutes to go around its bigger partner. After DART hit it, that orbit changed. The new time? 11 hours and 23 minutes. I mean, that is a clear, undeniable success. 32 minutes. It shaved 32 minutes off its orbit. Now, you might think, okay, 32 minutes, what's the big deal? Well, in space, that's a huge deal. A tiny nudge like that, given years or decades in advance, is literally the difference between a direct hit on Earth and a safe flyby. This was a monumental win for planetary defense. But here's the really fascinating science behind it all. The impact actually worked better than anyone predicted. And why? It turns out Dimorphos wasn't one solid rock. It was more like a loose pile of rubble, just barely held together by gravity. So when DART hit, it blew out this massive cloud of debris, and that spray of rock and dust acted like a rocket engine, giving the asteroid a huge extra push. What an amazing discovery. So, we can celebrate the success of DART, right? Humanity has a proven way to defend the planet. We're all good. Well, not quite. In fact, this huge success actually shines a light on a much, much bigger problem. And this, right here, is the heart of the issue. We proved we can move an asteroid. That's amazing. But it's totally useless if we get blindsided by one we never saw. You have to be able to see it coming, and you need to see it coming years in advance. And the scale of what we need to find is just staggering. Scientists estimate there are about 25,000 near-Earth asteroids out there in that dangerous city killer size range. 25,000. And if you want to see the problem in a single picture, this chart is it. Of those 25,000 potential threats, we've only found about 40% of them. That means more than half, 60%, are still out there, completely unknown to us, flying around in the dark. A lot of them are basically giant dark lumps of coal that don't reflect much light, making them incredibly hard to spot. So how do we fix this? How do you find thousands of nearly invisible asteroids flying around in our cosmic blind spot? Well, the answer is to look for them in a completely new way. And this is it. Meet the NEO Surveyor. It's a planned NASA space telescope designed to do one thing: find these asteroids. And instead of looking for faint, reflected sunlight, it's going to hunt for their heat. See, even a pitch-black asteroid soaks up heat from the sun and glows in infrared light. The NEO Surveyor is going to be our heat-seeking eye in the sky. And you know, DART's method of just smacking into something is only the beginning. Scientists are working on ideas that are straight out of science fiction. Things like laser ablation, zapping an asteroid with a laser to vaporize rock and create a little rocket engine. Or a gravity tractor, where a heavy spaceship would fly alongside an asteroid for years, and its tiny bit of gravity would slowly, gently tow it onto a new path. And yeah, for a really big one with little warning time, the nuclear option is still on the table as a last resort. So this is where we are. We've taken that first incredible step. We've proven that we are not the dinosaurs, that with enough warning, we can actually defend ourselves. The DART mission was an absolute triumph. But it all boils down to this one final question. We've proven we can move an asteroid. The challenge now is, can we find the one that's actually on its way?